here is at the restricted domain. If we didn't restrict the domain, it wouldn't be the square root function. It would just be the square root relation. And that's because it would fail the vertical line test. Now, the table representation, these are our smallest perfect squares. That's what your x's are. Your x's are your smallest perfect squares. And so when I ask for the square root of 0, what do I get? 0. Square root of 1, what do I get? 1. Square root of 4, what do I get? 2. Square root of 9, what do I get? 3. So these are our smallest perfect squares. And these are the values that we use when we're typically talking about our parent function. Okay. Our second representation here is function representation. So our function is written as f of x equals the square root of x. And we're saying when x is greater than or equal to 0, meaning that we want no negatives. Okay. Our third representation that we have is of a graph. So graphically, what does it look like? Well, it looks like a little arch. So it's a little arch. And when we look at this arch from left to right, it increases. Do we see it increasing? The domain of this graph, domain meaning how far left do we go? So reading from left, we go from 0 to infinity, which is why our domain is x is greater than or equal to 0. When we're looking at our range from bottom to top, we start at 0 and then we continue to infinity. So this is our domain and range written in inequality format. Our domain and range can also be written in interval, which would be 0 to infinity. Our x-intercept and our y-intercept are asking us, where do you cross the x and y axis? And that both takes place at the origin. Any questions so far about the parent function? We're good? Looks familiar? Okay, cool. Now, the next thing we're going to talk about are transformations. Just like all the other functions, there are transformations that take place, okay? Nothing's changing except the function that we're working with, but it's the same thing as prior to this with our square root, our quadratic, our absolute value, same effects. So first we have our vertical translation. Our vertical translation is going to affect the y values. So your vertical translation affect your y values, which means it's going to affect your range. Okay. So if you have a number out that's being added or subtracted outside of the square root, that's a vertical translation. If it's being added, it's going to go up. If it's being subtracted, then it's going to go down. That's why it says D is greater than 0 and D is less than 0, because they're either going to be added or subtracted. Okay. Horizontal translation. Horizontal translation means that the addition or subtraction is happening inside of the square root. Okay. So your addition and subtraction is happening inside of your square root. And this is going to affect this affects your x values. And a key thing we need to remember about our x values is that x's are liars. Okay. So when we see x minus c, that actually means that our c is positive. It's going to be shifted to the right. So it's going to look like a minus, but it means that c is actually positive and it's going to the right. If we saw x plus c, our c is actually less than 0, because that means it's negative and it's actually shifting to the left. Because x's are liars. All right. Sure. Vertical stretch and compression. Your vertical stretch and compression is changing how quickly or how slowly your y values increase. Okay. So here, when you have a number on the outside of the square root that's being multiplied, that's a stretch or a compression. Okay. So that stretch or compression is on the outside. If the absolute value, meaning regardless of whether it's negative, if it's greater than 1, that's a vertical stretch. If it's less than 1, that's a vertical compression. If you don't want to use the word compression, you can use the word shrink. okay? And this is going to affect our y's. Okay, now when you're taking into the consideration, if A is negative, that's a reflection in the x-axis. So it's going to reflect over the x-axis. So instead of our function forever increasing, it's now forever decreasing. All right, our horizontal stretch and compression. Again here, x's are liars. Mathematically, it looks like you're going to be multiplying each one of your x values, but in reality, what you're doing is dividing them, okay? Just like here, we look like we're subtracting, we're actually adding. Same thing here, it looks like we are multiplying, but we're dividing. And that's why the effects are opposite. So if B is greater, if the absolute value of B is greater than 1, it's a horizontal compression because I'm dividing the x values. If absolute value of B is less than 1, it's a horizontal stretch. And again, this is affecting our x values. Okay. Reflection. So if your B is negative, it's a reflection in the y-axis, which means that your function is reflecting over the y-axis. So instead of it doing this, it's now going, pretend that as a curve, not a line. I try to make it a curve, but curve as well. Okay, so when we put it all together, the transformation function for the square root function would look like f of x equals a absolute value of b times x minus c plus d, where each piece has a role that it plays. What are your questions about the transformation rules? One question may be, why do I need to know this? Well, transformations are useful when you don't have a device to do the graphing for you. You can do the graphing for yourself and be able to analyze and describe it, which we're going to model here in a minute. It's all right. We all got to do things and deal with people we don't like. Part of life. All right, so we're going to analyze this graph. F of x equals the square root of x minus 1. First, we're going to draw on our axis. So there's my y-axis. And there's my x-axis, and we're going to pretend that those are super straight lines. That doesn't really matter. Okay, personally, the first thing I feel like you should do when you are analyzing a graph is to draw in its parent function. So I'm going to draw my parent function. Remember, the parent function of this are what are our smallest perfect squares and their roots, right? So that's 0, 1, 4, and 9. So I'm starting at 0 because the square root of 0 is 0. 1, square root of 1 is 1. 4, the square root of 4 is 2. So that is my parent function. And I'm asking, and it's asking what is what? Oh. So this is our f of x. And our f of x is saying that we're taking the parent function and we're changing it by subtracting 1. What translation or transformation does that represent? The minus 1. Is that my A, my B, my C, or my D? It's my D. My D equals -1. It's something being added or subtracted on the outside, right? So I'm subtracting. So D equals -1. And we said that if D is less than 0, that means it's a vertical translation down. Right? So that's a vertical translation down. So what that tells me is that each one of these points in my parent function is going to be shifted down one. So now it's here, here, here. I went down too much on that one. So here's my f of x. So if you were to look at a table to do this, so remember our parent function table where we had, it said your x's are 0, 1, 2, 4, and 9. And your y's were 0, 1, 2, and 3. What this translation is saying that, remember, it affects your y values. So to each one of your y values, you're subtracting 1, which is why physically we just shuffled down 1. And that puts us at -1, 0, 1, and 2. Does that make sense? Yeah. So we see it physically on the graph, and then do you see what happened on the table? So that's why 0's at -1, 1's at 0, 4 is at 1 now. And then if it would continue. All right, so now we're going to stripe the domain and range. So the domain here, where does it start? Our domain starts at 0 and continues to infinity, right? So our domain is x is greater than or equal to 0. Our range, where does our range start at now? Did someone say -1? Our range starts at -1, but continues to infinity. So our range is y is greater than or equal to -1. Okay, even though it doesn't say it, I want us to analyze our intercepts. So our intercepts, where do we cross the x and y axis looking at our f of x, the red graph? Intercepts. Where do I intersect the graph, the axis? 0, -1, and where else? 1, 0, right? Here are my intercepts. I cross at 0, -1, and I cross at 1, 0. Okay, looking at what we have, could you comfortably either graph and analyze or look at the table and analyze a transformation? Yeah. Okay. Let's do another one. But I'm going to pause and I would like for you, I'm going to give you 2 minutes to do this one. So you're doing what we did on example 1 on example 2, and then we're going to come back. I believe in you. You're welcome. Vinay, can you hear me?
Yes.
Okay, cool. All right. So here we have the graph, square root of x minus 3. Draw the straightest lines you've ever seen. Look here, straightest lines you've ever seen. And I'm going to put in my parent function real quick because it doesn't take that long. So here's my PF, my parent function. And then looking at what I have f of x equals the square root of x minus 3. I have -3, which means d equals -3. So that's a translation down. Okay, so that means I'm taking each one of these points and I'm taking them down 3. And it's like, so here's my f of x. So the domain here, I'm from 0 to infinity, which means that x is greater than or equal to 0. My range here starts at -3. So my range is y is greater than or equal to -3. My intercept is what this one is focusing on, x and y intercept. Well, I can see my y intercept. My y intercept is where? 0, -3. Agreed? However, the problem is, can I see my x-intercept? No, I cannot see my x-intercept because it goes off the screen. These arrows mean that this is going on forever. Just because I can't see it doesn't mean it doesn't exist. So when you can't see an intercept on the graph, what you can do is solve it by hand. To find your x-intercept, that means that your f of x is going to equal 0. That means your y is going to equal 0, right? So if I take 0 and set it equal to my function, I can always find my x-intercept. You should have plenty of room. All right. So what would I need to do to get x by itself? I would need to add 3. So that cancels out the 3's on the right side, leaves me with 3 equals the square root of x. How do you cancel out a square root? Square it. And what is 3 squared? 9. So therefore, my x-intercept, if this graph would continue, my x-intercept would be at 9, 0. Okay. All right, what are your questions, comments, or concerns? Okay. All right, so for the next few examples, you either can use a handheld calculator or Desmos graphing calculator. The only hiccup is I got to make sure or double check that if you choose to use Desmos and you get comfortable with Desmos, that our test isn't in lockdown browser. Because if our test is in lockdown browser, guess what that means? Can't use Desmos. For this though, I'm not going to use Desmos. I'm going to use the handheld on my computer. But it says to graph f of x equals 2 minus the square root of x and find the maximum and minimum values over the interval from 1 to 6. Okay, so I'm analyzing not the whole graph, just from 1 to 6. Does that make sense? All right, so I'm going to graph this 2 minus the square root of x, and I'm going to see where it's a max and a min. Okay, because our absolute value function is either going to be increasing or decreasing, that means that my max and min is either at the beginning or at the end. Does that make sense? So I only have to analyze what's happening at 1 and what's happening at 6. Okay, so if you chose to do it without the calculator, you're just comparing these two values. It wouldn't be easy for 6 because is 6 a perfect square? No, 6 isn't a perfect square, so it wouldn't be that pretty, but we're going to do that. Okay, so let's go to graph. My handy dandy calculadora. I'm going to start a new graph. Never save. Okay, so we're going to be putting in 2 minus the square root of x. So we're going to hit enter. And like we said, we're analyzing. From here, we knew that the 2 lets us know that it was shifted up 2. See how it was shifted up 2 units? The negative lets us know that it was reflected. Do we see that? So all of that is coming to play. Now to analyze the graph, I'm going to go to menu, trace. I'm going to graph trace. My interval that I'm analyzing is from 1 to 6. So I'm going to start with 1 and find the value of 1. So here's the value of 1. And the value of 1 is 1, 1. Now I'm going to go to 6, find the value of 6, hit enter, and there's the value of 6. Can I clearly see what's my max and what's my min? Yeah. My maximum value is 1, and my minimum value is negative 0.45. Yes. I round it.
Why is your graph going down? My graph going up.
Because I put mine in correctly.
I put mine in correctly.
You put in 2 minus the square root of x? Or did you sure? I don't think you did. All right, so our maximum took place at x equals 1, and the value was 1. Y equals 1. Where that's your X, the value is your Y. Okay. Our minimum took place at X equals 6. And the value was Y equals negative and 4,500. How do you feel about analyzing the maximum and minimum of a square root function?
Wait, can you go back on
Mhm.
the menu part?
I can. So on the menu part, if you're using the handheld, it's menu. Then you're going to go to 5 for trace, and then it's 1 for graph trace.
Okay.
And that allows you to type in whatever value you need and hit enter. So we needed 1.
Okay.
All right, so next we're gonna do describing and using transformation. So normally I would like, oh, no calculator. However, I'm gonna allow you to graph if you need to, but you also can use the table to analyze. So when you're graphing, I would like for you to at least identify the transformation that's gonna take place first, okay? So if I look right here, I have y equals 2 square root of x, right? That 2 is at A, B, C, or D. Which transformation value is that? A. So we know that A equals 2. Do we see that? And because A equals 2 and the absolute value of this is greater than 1, what is happening to this function? It's a what? It's not a reflection. It's greater than 1. So we said A. And what does it mean when A, the absolute value of A is greater than 1? It's a vertical stretch. So we have a vertical stretch by 2. Okay, which means is our domain affected? Or what does that affect? That only affects our Y, right? Okay, but it is not shifting it. Is it making it go left, right, or up or down? No. So our domain is still going to be X is greater than or equal to 0. Our range is still going to be Y is greater than or equal to 0, which means that our intercepts are still going to be at 0, 0. Now, this is if you're using your transformations. If you're still hesitant, not comfortable, I'm going to do example B using the calculator. Is that cool? All right. So just for facts, we see here that it's something being multiplied by the square root. So that lets us know that this is our A, right? Our A equals negative 1/4. A equaling negative 1/4 tells us not just one thing, but tells us 2 things. The first thing it tells us is that it's a vertical compression or shrink, whichever one you want to write. I don't feel like writing the word compression. So it's a vertical shrink by 1/4 because the absolute value of this is less than 1. The second thing it tells us is that it's a reflection. Is it?
Oh my God.
Oh my gosh. Over the x-axis. Okay, because I did not shift left, right, or up or down, that means that my domain and my range are not being affected. So all of these are still going to be the same. I guess tomorrow we will look at how to do it in the calculator. Nope, no work until tomorrow. 1:30.
Everybody does.
Okay, so continue where we left off yesterday. We were talking about transformations. Yesterday, we talked about vertical, what were we at? We talked about vertical stretch and shrink, right? So today we're going to start off with vertical shifts, translations. So when we look right here, we have y equals the square root of x plus 2. So this plus 2, that's the change from our parent function, right? That's what changed. That's our d variable for translations. So if d equals 2, that means that that's our up and down motion, right? So we know this is a vertical translation up. because D equals +2. Versus if you look here, example D, the change from our parent function is -3. So D equals -3, and therefore this is a vertical translation down. Okay, we're going to look at the graphs of each one of these and compare their domain and range to the original function, okay, to our parent function. So if you have your calculator out, please follow along. If not, please grab a calculator. I'm going to start a new document. No, I don't want to save. Okay, when you're comparing transformations, you always want to start with your parent function. So my parent function is just square root of x, right? So this is going to stay on the graph the entire time. Nothing is going to change from here. So I'm going to hit tab and I'm going to put in the first one, which was square root of x plus 2. So now this has been transformed. So I'm going to describe the domain and range of the transformation. So what's the domain and range of this graph? What's the domain? Where does it start? Starts where? Starts at 0, Ms. Jones. Oh, awesome. The domain starts at 0 and it continues to infinity. Okay, the range starts where? At 2. The range starts at 2 and continues to infinity. And in terms of intercepts, I only have a y-intercept, right? And my y-intercept is at 2, 0, 2. Do we all see that? All right, so those are the attributes of this function. That's what we're going to write down. So we have our domain starts at 0 and continues to infinity. So x is greater than or equal to 0. Our range started at 2 and continues to infinity. So x is greater than or equal to 2. And our intercept was only at 0, 2. How do we feel about that? Doable? All right, so we're gonna do the same thing. We're gonna analyze -3. So I'm gonna go back. You can, if you're using a handheld, there's a couple ways. You can double click on that or hit tab and it'll still take you there. But I'm gonna take the plus, turn it to a minus. And so now here's my function. So for this function, what's its domain? 0 to infinity, right? Starts at 0, continues to infinity. What is its range? -3 to infinity, right? Because now my lowest y value is -3. What are its intercepts? 0, -3, and 9. Okay, if you're wanting to be quick at counting, if you hit menu 5, 1, click on the graph you want. So I want this graph. You can trace and it'll tell you if you're like, I don't know where my 0 is. You can trace it and it'll tell you where your 0 is. Menu 5, 1. All right, so that's us. That's analyzing. That's all analyzing is. How do we feel about analyzing? Great. Is it doable? All right, so from here, our domain is unchanged. So it's still x is greater than or equal to 0. The range started now at -3 and went to infinity. That is a horrible y, by the way. And our y is greater than or equal to -3. And our intercepts are at 0, -3, and 9, 0. And that's what you are hopefully being able to do. Describe the transformation and analyze the graph. Describe the transformations and analyze the graphs. How do we feel so far? All right, so we've done our verticals. Now we're going to move into horizontal. Okay, so we have our horizontal. On your paper, it looks like the bar stops, but it should go all the way across. So it should say the square root all the way across x -3, x plus 2. Okay, it is all underneath the square root. All right, so we're inside of the square root. which means that this is our C variable for transformation. And our C variable for transformation, we must remember that X's are what? Liars. So it looks like a -3, but it's actually a +3. So C equals +3. Because C equals +3, that means we're going horizontal translation to the right. So it's a horizontal translation to the right. All right. Over here, we have a +2. And again, our X's are, so it's not a +2, it's actually a -2. So it's a horizontal translation to the left. So when it's asking you to describe your transformations, this is what it's asking you to do. How do you feel about describing horizontal translations? Easy enough? All right, now we're going to analyze the graph. So we're going to analyze their domain, their range, and their intercept, okay? Because we're horizontally moving, which one is going to change, our domain or our range? Our domain, because that's our horizontal, right? Our X values are changing. So let's go look at that. So again, I'm going to double click here because I want to change my X -3. And now it's going to be under the square root X +2, right? Is that what I had? Okay. And were we right about our transformation? Did it go to the left too? Yes. Now we're going to analyze its intercepts, okay? So I'm in its domain and range. So my domain now starts where? -2. Do we all see that? So it starts at -2 and continues to grow to infinity, right? My range was my range. Did my range change? No. My lowest Y value is still at 0. Agree? All right. Now next, our intercepts. What is my X intercept? -2, 0, right? My Y intercept is an approximate value. And so we can look at the decimal value, but we're also going to write the exact value. Does that make sense? So our decimal value is travel, boom, 1 and 41/100ths. And it literally tells you that's your Y intercept. It's kind of foolproof. All right, so let's list out the things we learned here. So we have our domain. Our domain now starts at, oh, it's -3. Dadgummit. Okay, I'll write it on the other side. I put in the wrong one first. You never saw that. Domain over this side starts at -2. So therefore, X is greater than or equal to -2. Our range was unchanged, so Y is still greater than or equal to 0. Our intercepts are different, right? So our intercepts, we have obviously -2, 0. The other one was an approximation at 0 and 1 and 41/100ths. The real one, to get your exact value, all you're doing is plugging in 0. So to get your exact value, you would plug in 0 plus 2. And what is 0 plus 2? 2. So this equals 0, the square root of 2. Okay. On your Savas, if it asks for exact, it's going to want you to put the radical. If it asks for approximate, then you would put the 1 and 41. Okay, so I'm going to pause for a moment and I want you to find the domain, range, and intercepts for Y equals the square root of X -3. All right. All right, let's see how we did. So for the square root of X -3, when I go to my graph, I'm going to change this bad boy from +2 to -3. Hit enter. And did it go to the right like we said? Yes. And for this one, do I have a y-intercept? No, I never crossed the y-axis. So therefore I have no y-intercept, but I do have a special x-intercept right here. And that's at 3, 0. So this is where my domain begins. Was my range changed? Did my range change? No. So the domain now started at 3 and went to infinity. So x had to be greater than or equal to 3. My range did not change. And my intercept is only at 3, 0. No, it's not there. You only put it where it's at. All right, how do we feel about horizontal translations? Doable? Yes. All right, so now we're going to move into horizontal shrink and stretch. Okay, so here, that means we're working with our b variable. So in this one, b equals 5. Okay, remember our x's are liars. So we would think that this would be a stretch, but it's the opposite. It's actually a shrink. That's because it's greater than 1. So this is greater than 1. So this is actually a horizontal shrink. I hope I spelled that right. I think so. All right. With that same token on this side, our b, well, the b here, the absolute value of our b is 1/2. And 1/2 is less than 1. And less than 1 is actually a stretch. X's have to be difficult, I tell you. Okay, now this one also has a negative. So paying attention to the negative means that you have, so not only did it horizontally stretch, but it also did what? It reflected, right? So we stretched and we reflect. It's always the opposite. So if the negative is with x, then it's going to reflect over the y. If the negative is with the y, it's going to reflect over the x. So in this case, our negative is with the x, so it's a reflection over the opposite, over the y. All right, so those are our transformations. Now we're going to graph and analyze the domain, range, and intercepts. Cool? So we have, double tap, the square root of 5x, right? All right, so it's shrink, which just means that you went in. So it's shrink. And did our intercept change? No. It's just zeros are still there, right? Did our intercepts change? No. Did our domain and range change? No. So therefore, it's still going to be x is greater than or equal to 0, and y is greater than or equal to 0, and we're still chilling at 0, 0. Okay, now let's look at the negative. How does the negative affect us? So we have negative 1/2. And we said that it's going to cause it to reflect over the y-axis. Boom. I'm like a bird. I want to play. That's a song. I don't remember that song. All right, so was our y values affected? No, just our what? Our x's. But so the domain of the x, reading from left to right, where do our x values start? Left. They're going forever to the left. What is that called? Negative infinity. So they go from negative infinity to 0. So our domain changed to this. Because of the reflection, our domain goes from negative infinity to 0, which means that x is less than or equal to 0 now.
Do you have to write the pair? Or can you just write?
No, the pair is just the way your set notation, your interval notation is just to help you make sure you do your inequality right. Our range is unchanged, and so are our y-intercept. All right, so here's the real test. Putting it all together. So if you look at I, you have every single variable represented. Do you see that? Every single variable is represented. So based on that, I would like for you to take a moment and write out the transformations without graphing that you think took place without graphing. So without graphing, what transformations took place just looking at what you have? Yes, there's all variables represented, so there better be multiples. All right, so first you have your A variable, right? And A equals 3, because A equals 3, that is a vertical stretch. Okay, then we have our B variable. Our B equals 2. So that's a horizontal shrink. Yes? All right, this is where it gets tricky. What did y'all put for C? Okay. All right. All right, so this is the trick right here. If you go back, if you remember how we wrote our transformation rule, so for our transformation rule, it has to be a square root of b x minus c plus d. Is this in that format? No. So in order to know what your c really is, you have to divide out your b. So this is really 3 square root of 2x plus 1 minus 4. So your c actually equals 1, which means that it went -1, I'm sorry. So that means it went left. It's okay, I'll let you figure that, I'll let you go through that on your own on purpose. And then lastly, our D, and our D affects our Y, lie, it's just -4. So it went down 4. So those are all 4 of the translations that took place. Okay, so that means when you're looking at this, your domain and your range have both been affected. Does that make sense? My domain now starts at -1 and continues to infinity. My range now starts at -4 and continues to infinity. So X has to be greater than or equal to -1, and Y has to be greater than or equal to -4. And you can graph to verify. Because your C and D were changed. So when your C and your D are altered, it changes your domain and range automatically. Good question. Okay. All right, so just to recap the factoring thing, I just wanted to go over that with you again. Notice here how we have the square root of 9x minus 36. I know what my A is, but do I know what my C is? No. In order to find your C, you have to divide, B. You have to divide by the B value. So I have to divide by that 9 to know what my C actually is. And that's going to leave me with 9. And what's 36 divided by 9? 4. So now I can say that B equals 9 and C equals 4. Because B equals 9, that's a horizontal what? Shrink, good job. And since C equals 4, that's a horizontal, we went which way? We went which way, left or right?
Right.
Right. Went right. Okay, and because there's a C value, my domain is what? Changed. So my domain now starts where? At 4. So my domain now starts at 4 and continues to infinity.